What I want to show you here is three simple hashing algorithms just to have more of an understanding of what's going on behind the covers. So what this example does is it just loops on a console window, prompting for some input, reading the input, and then printing out three different hashes. The additive hash, which is the hash we looked at where the sum of all the ASCII values are returned. The folding hash, which was a hash we looked at where each 4 bytes in the string are compressed into an integer and those integers are summed together. There are slides for both additive and folding. If you want to go back and look at those to refresh yourself, that would be great. And then the last one is called the DJB2 hash. This was a hash that was published on the CompLang C news group quite a few years ago. You can find a lot more information about it online. In fact, I have a link to it in the source code. So if you're curious, you can take a look at it, learn more about its characteristics. I put it in here just to show you another really small, tight hashing function that does some different things. It's a little bit kind of off the trail that we've looked at so far, and it's not a bad jumping off point to learn more about hashing. So the additive hash, we store the current value, we increment every time, we return the current value. One convention I want you to notice here is that I'm using unchecked. And the reason is that in C#, when you're doing integer math, if you overflow the integer, it's going to throw an exception unless you have it in an unchecked block, in which case it's going to wrap around from positive to negative. So it's just something that we need to do in order to have the integer math work the way we expect. DJB2, if you really want to understand more of what's going on, like this magic number of 5381 and why we're doing the shifting as opposed to multiplication, go ahead and look at the link for it. I don't want to dive too deep into it because it's not really the point of this. The point was just to show you some different hashing algorithms and how some of them are simplistic and small, 6 lines long, and some are longer. And then we have the folding hash. And here, this is where we're compressing every 4 bytes down into an integer. And what it's doing is it's actually this get next byte method is doing some bit shifting to build up the current 4 bytes. Get byte will return, the byte or 0 if we're out of string characters. Go ahead and take a look and understand it a bit more, but it's pretty straightforward code. Again, the point is to give you some examples of different algorithms, not necessarily to show you the best or the right way to do things. So let's take a look at it in action. We're going to pass in foo. Now you can see with the additive hash, the value is 324. Folding and DJB2 have much larger different values. And now here's where additive hash falls apart. If I pass in oof, again the value is 324. So that's that uniformity thing we were talking about. It's not providing hash values for unique strings across the array of available values. Where you can see that folding in DJB2 provided values that were quite a bit different than the previous. So we can provide any length string we want, and what you'll notice is that additive values keep getting bigger as the strings get bigger. So this is a long string. And you can see the things have wrapped around to negative, and that's an example of where if we hadn't used the unchecked keyword, we would have thrown exceptions there. So if you're curious and you want to learn more about hashing, spend a little bit of time going through this, maybe follow some of the links to learn more about the specific algorithms.